A warm good afternoon to one and all. I am Lakshmi Prabha from TTWRDC Women, KHAMMAM. I am pursuing graduation under the course of B.Sc MBCS in the final year. Today, I am going to give a lecture on differential equations topic in the mathematics. First of all, I would like to thank head office for giving students these wonderful opportunities in these pandemic situations. Before going to know about what a differential equation, we should know some basic introduction of a differential equation. The introduction of the differential equation is the differential equations first came into existence by Newton and Leibniz, who also invented calculus. These two scientists are responsible for the invention of differential equations. The differential equations are of great importance in engineering and science because many physical laws appear to be in the form of differential equations. Not only that, the differential equations are widely used in real life problems and they are also used in different domains of mathematics, physics, chemistry, economics, and life sciences, etc. Now, we are going to know what a differential equation is. A differential equation is nothing but it is an equation involving one independent and dependent variables and their derivatives is called a differential equation. Once again I am repeating, a differential equation is nothing but an equation involving independent and dependent variables and then derivatives is called a differential equation. Let us consider an equation f of x is equal to dy by dx. Here in the above equation, y is a dependent variable and x is an independent variable. It means that the value of y depends on the value of x. Here the derivative dy by dx can also be represented as y dash or f dash of x. This is about differential equation. Let us see some of the examples of differential equations. Let the first example be dy by dx is equal to 7x plus 2. And the second example is y dash is equal to y dash minus 2. And the third differential equation is f of x is equal to 7 minus f dash of x plus x into f double dash of x. And the fourth differential equation is dy by dx is equal to 5x. These four are all the examples of differential equations. Now, based on the type of variables, the differential equations are classified into two types. They are first one ordinary differential equation and the second one is partial differential equation. First one, we are going to know about ordinary differential equation at first. Ordinary differential equation is nothing but a differential equation which involves derivatives with respect to a single independent variable is known as an ordinary differential equation. Let me once again read the definition. A differential equation which involves derivatives with respect to a single independent variable is known as an ordinary differential equation. Let us see some of the examples of ordinary differential equations. First one, x plus y dy by dx is equal to 0. And the second one is d square y by dx square minus 2x dy by dx plus 2ky is equal to 0. And the third differential equation is y is equal to under root of x dy by dx plus k dy by dx and so on. These five are the examples of the ordinary differential equation. If you observe keenly these examples, we find that in all the examples there is only one or single independent variable which is known as x. X is a single independent variable in all these equations. Now, let us see what a partial differential equation is. Partial differential equation means a differential equation which contains two or more independent variables and partial derivatives with respect to them is called a partial differential equation. Once again I am explaining. A differential equation which contains two or more independent variables and partial derivatives with respect to them is called a partial differential equation. Here, in case of partial differential equation, we are having two or more independent variables and also partial derivatives with respect to them. This is known as partial differential equation. Let us observe some of the examples given here. The first example is dou square y by dou x square plus dou square y by dou y square plus dou square y by dou z square is equal to 0. Here in this example 1, x comma y comma z are three independent variables, and in second equation dou square y by dou t square is equal to a square dou square y by dou x square. Here we are having two independent variables, they are x comma t. And also in the third example we are also having two independent variables, they are x comma t, and here dou is a partial derivative. So the major difference that we need to observe between the ordinary differential equation and a partial differential equation is that in the case of ordinary differential equation we are having derivatives with respect to a single independent variable, but in case of partial differential equations we are having two or more independent variables and partial derivatives with respect to them. So we need to remember this point in case of ordinary differential equation and partial differential equation. Now let us go through order of a differential equation and what an order of differential equation is. The order of the highest order derivative involved in a differential equation is called order of a differential equation. Here let us observe the examples given here. The first example is d cube y by dx cube plus 5 d square y by dx square plus y is equal to 0. In this example, the order of the highest order derivative is 3. Here, the highest order derivative is d cube y by dx cube and the order of the highest order derivative is 3. So, we are taking order is equal to 3. And in the case of second example, x plus dy by dx is equal to 0. Here, we are having only one derivative, that is dy by dx. That means only one derivative, so we are taking the order of the derivative which is given, that is the order of the dy by dx which is 1, so order is equal to 1. In the case of third example, d square y by dx square minus 4x dy by dx plus 3ky is equal to 0. Here we are having highest order derivative is d square y by dx square. So the order of highest order derivative is 2. So order is equal to 2. So here we are having first order differential equations, second order differential equations, and so on nth order differential equations. When we say a differential equation is a first order differential equation means when the order of a given differential equation is 1, then it is known as a first order differential equation, and when the order of the differential equation is 2, then the differential equation is known as second order differential equation, and so on. When the order of a given differential equation is n, then that differential equation is said to be as a nth order differential equation. So these are first, second, and so on nth order differential equation. So let us know what degree of a differential equation is. A degree of a differential equation is nothing but the power of the highest order derivative when the differential equation is free from fractional powers. Here we need to keenly observe one thing, that here the power of the highest order derivative when the differential equation must be free from fractional powers, means the differential equation should not contain fractional powers, then only we can find degree. By having fractional powers we'll get a wrong degree, so we should remember this thing. Let us see examples. The example 1 is that d square y by dx square whole cube minus dy by dx whole power 2 by 3 whole cube is equal to 0. Here actually the equation is d square y by dx square minus dy by dx whole power 2 by 3 is equal to 0. For getting the degree, for removing the fractional powers, we are cubing this equation and taking to other side. By solving this equation, we are getting the equation as d square y by dx square whole cube minus d square y by minus dy by dx whole square is equal to 0. So, here order is equal to 2 and degree is equal to 3. Let us observe second example. D square y by dx square plus 5 dy by dx whole power 2 by 3 plus y is equal to 0. Same in the case of above example, if we solve this equation by cubing on both sides, we get the following equation, that is d square y by dx square whole cube is equal to 5 into dy by dx whole power 2 by 3 minus y whole cube. By solving this equation, we get order is equal to 2 and degree is equal to 1. This is the most important thing that we need to remember, is that the differential equation should be free from fractional powers while finding the degree of a differential equation. Now, let us know about differential equation solutions. How to find the solutions of the given differential equations. There exist two methods to find the solutions of the differential equations. The first method is separation of variables, that is known as variable separable method, and the second method is integrating factor method. First of all, we shall go through variable separable method, that is separation of variable method. The differential equations which are expressed in terms of x comma y such that the x terms and y terms can be separated to different sides of the equation. Thus, each variable separated can be easily integrated to form the solution of the differential equation. That means here every equation that which is a differential equation containing both x and y terms. So, to find the variable separable method of solution, we need to separate the variables x and y to different sides and integrate easily to find the solution of given differential equation. Let the equation can be written as f of x dx plus g of y dy is equal to 0. G of y dy is equal to 0. After separating the variables x and y, the equation can be written like f of x dx plus g of y dy is equal to 0, where f of x comma g of y are either constants or functions of x comma y respectively. Now let us observe one example how to solve the differential equation using variable separable method. Let us take example dy by dx is equal to x cube plus 3 by y square plus 1. Here we need to separate both the variables x and y. So we are separating x variables on one side and the y variable on other side. So by separating the x and y variables, we are getting the equation as y square plus 1 dy is equal to x cube plus 3 into dx. So, Now we separated both x and y terms so that we can easily integrate these terms. By integrating these terms, we get integration of y square plus 1 dy is equal to integration of x cube plus 3 into dx. So integration of y square dy is nothing but y cube by 3, and integration of 1 dy is y, that is y cube by 3 plus y is equal to x power 4 by 4 plus 3x plus c. Here, while integrating, we will get a constant. So, the final general solution of the given differential equation using variable separable method is that y cube by 3 plus y minus x power 4 by 4 minus 3x is equal to c. This is known as variable separable method of finding solution of the given differential equation. Now let us see the second method of finding solution of the differential equation, that is integrating factor. The integrating factor technique is used when the differential equation is of the form dy by dx plus p of x y plus is equal to q of x, where p comma q are both functions of x only. In this integrating factor technique, the differential equation should be of the form dy by dx plus p of x y is equal to q of x, where p comma q are both or in terms of x only. So here we are having the formula for integrating factor and for finding the general solution, that is integrating factor is equal to exponent of integrate e power the formula for finding general. Let us know how to find the differential equation of a how to y dash plus 2x y is dy by dx is equal to 4x. The given equation form dy by dx plus p of x into y is equal to q of x. So here the p of x term is equal to 2x and the q of x is equal to 4x. So we have known p of x and q of x term. So we need to find the integrating factor. So integrating factor is equal to e power integration of p of x dx. Here p of x means 2x. So e power integration of 2x dx is equal to e power x square, where the integration of x is x square by 2. So we are getting integrating factor is equal to e power x square. So by using the formula of general solution, we can find the solution of the given differential equation, that is general solution is y into integrating factor is equal to integration of q of x into integrating factor into dx plus c. So y into e power x square is equal to integration of 4x e power x square dx plus c. So by solving this equation, we are getting the final general solution as y is equal to 2 plus c into e power minus x square. Here, for thoroughly getting the solution, we are using a formula, that is f dash of x into e power f of x dx is equal to e power f of x. For that, we are writing the term integration of 4x into e power x square dx plus c as 2 into integration of 2x e power x square dx plus c for thoroughly getting the solution. So we need to remember this formula is important for some problems. So in this way we are finding the general solution of a differential equation in integrating factor method. So we have learnt about how to find the solutions by using variable separable method and integrating factor method. Now let us see exact differential equations of first order and first degree and how to find the solution of the exact differential equations. So exact differential equations is of the form mdx plus ndy is equal to 0. So in the equation mdx plus ndy is equal to 0 if the partial differentiation of m with respect to y is equal to partial differentiation of n with respect to x, then this equation is said to be exact solution of exact differential equation is. So in the equation mdx plus ndy is equal to 0 if dou n by dou y is equal to dou n by dou x, then this equation is said to be an exact differential equation. So how to find the solution of exact differential equation is by using the formula integration of m dx where y is constant plus integration of n dy where no constant x terms are taken is equal to constant. By using this equation, we are going to find the solution of the exact differential equation. So, by taking one example, let us understand clearly. So, the example is x e power xy dy plus 2y dy plus y into e power xy dx is equal to 0. So, here we are writing all the y terms and x terms together, all the y terms separately together and all the x terms separately together. So here we are making the equation in the form of m dx plus n dy. By writing like that, the equation becomes y into e power xy dx plus x into e power xy plus 2y into dy. So it is in the form of m dx plus n dy is equal to 0. So here m is equal to y into e power xy and n is equal to x e power xy plus 2y. So now we are partially differentiating m with respect to y. Dou by dou y of y into e power xy is equal to, here it is in the form of uv. So the differentiation of u is u dash v plus v dash u. By solving this, we are getting e power xy into 1 plus xy. Similarly, we are finding the differentiation of n with respect to x partially. That is dou by dou x of x e power xy plus 2y. We are differentiating to x. So to x plus 0. So by dou y and dou n by dou x. So the given difference dou m by dou y is equal to dou integration of n dx where is equal to constant. we get y square equal to c. Here integration of y e power xy dx is equal to 0 because integration of m dx. In that case y terms are constant, so here we are having multiple of y, so integration of y e power xy is 0 plus in the term integration of n dy the x terms are not taken, so here we are having x e power xy term, so it becomes 0. So finally we get only integration of 2y dy is equal to c. By integrating it we get y square is equal to c, which is known as the final general solution of the given differential equation, which is exact. So we have learned about how to find the solution of exact differential equation. Next we are going to know about what are linear and non-linear differential equations. Based on the degree of a differential equations, we have linear differential equations and non-linear differential equations. So in case of linear differential equations, what is a linear differential equation means? A differential equation whose degree is 1 is called as a linear differential equation. Order may be anything but degree must be equal to 1, which is known as a linear differential equation. Here, while while knowing about the what is a linear differential equation, it is based on degree. So when we come across degree, we should mainly important one thing, that is that in degree we are taking the power of the highest order derivative of an equation which is free from fractional powers. We should remember this thing carefully, that is the equation must be free from fractional powers, then only we have to find degree of differential equation. If we are finding degree by having fractional powers in differential equation, then our answer will be wrong. So let us see the example of linear differential equation, that is d square y by dx square plus 5 dy by dx plus y is equal to 0. Here the highest order derivative is d square y by dx square. The power of d square y by dx square is 1. If nothing is there as power, then it is 1 we have to take. So the degree is equal to 1. And second, non-linear differential equation. A differential equation whose degree is greater than 1 is called a non-linear differential equation. Order may be anything but the degree must be greater than 1. Then the differential equation is said to be a non-linear differential equation. That is, let us see one example. Y into d square y by dx square whole square plus 5 into dy by dx plus y is equal to 0. Here the highest order derivative is d square y by dx square, which is having 2 as power. So the degree is 2, which is greater than 1. So it is known as a non-linear differential equation. Now we are going to know about homogeneous and non-homogeneous differential equation. First of all, we are going to know what a homogeneous differential equation is and how to find the solution of a homogeneous differential equation. A differential equation which is of the form m dx plus n dy, where m comma n are both of same order, is called a homogeneous differential equation. Here we need to remember one thing, that in case of homogeneous differential equations, the m comma n terms order is same. So let us see some examples of homogeneous differential equations. That is, first one, y dash is equal to 2y power 4 plus x power 4 by xy cube. And the second equation is y dash is equal to xy by x square minus y square. And the third one is x square y dash is equal to x square plus xy plus y square. In In the above all three equations, we are having degree same. We are having order as 2 and 3, means that means same order we are having. In equation 1, in all terms we are having order 4, and the second equation we are having 2 as order, that is same for all terms. So in all these examples we are having same order. So now let us take one example and find how to find and know how to find the solution of a homogeneous differential equation. Here we are taking the equation as y dash is equal to x plus y by x. By putting y is equal to vx and differentiating that, we can find the solution of this equation. That is, here we are taking the equation y dash is equal to x plus y by x. We can write y dash as dy by dx. So dy by dx is equal to x plus y by x. So we are writing this equation in the form of m dx plus n dy is equal to 0. Since homogeneous equation should be in the form of m dx plus n dy is equal to 0. So now by putting y is equal to vx and differentiating y is equal to vx, we are getting y dash is equal to vx, y dash is equal to v plus x dv by dx, and from our equation we have y dash is equal to x plus y by x. So we are equating both the equations, that is y dash is equal to x plus y by x and y dash is equal to v plus x dv by dx. So we get v plus x dv by dx is equal to x plus y by x. So v plus x dv by dx is equal to 1 plus y by x. We know that y by x is equal to v. Since from y is equal to vx, we get v is equal to y by x. So substituting y by x is equal to v in that equation, we are getting v plus x dv by dx is equal to 1 plus v. So both sides v gets cancelled and we get x dv by dx is equal to 1. Finally we get dv is equal to dx by x. So by integrating this one, easily we will get the solution of the homogeneous differential equation. So on integrating, we get integration of dv is equal to integration of 1 by x dx. So integration of dv is nothing but v, and integration of 1 by x dx is log e x plus c. That is, we know that v is equal to y by x. So substituting v is equal to y by x in this equation, we get y by x is equal to log base x plus c. So finally we get the general solution of the homogeneous differential equation as y is equal to x log base x plus c by x. So this is the method to find the solution of the homogeneous differential equation by using y is equal to vx. Not only we can take y is equal to vx, we can take other variables also for our convenience. So this is the process to find the solution of the homogeneous differential equations. So next we are going to know about non-homogeneous differential equation. What is a non-homogeneous differential equation? Means a differential equation is of the form m dx plus n dy is equal to 0, where the terms m comma n are not of the same order, is known as a non-homogeneous differential equation. Here, if you observe the example, xy dash is equal to x square plus y x plus y square x. We are having different orders, that is 2 we are having, 3 we are having, so that means the orders are not same. So that's why this equation is said to be a non-homogeneous differential equation. So Till now we have learnt about what is a differential equation and what are the different types of differential equations, that is ordinary differential equation, partial differential equation, and what is order of a differential equation and degree of a differential equation, and how to find the solutions to the given differential equations by using variable separable method, integrating factor method, and how to find exact differential equation and its solution, and how to find the solution to homogeneous differential equations and non-homogeneous differential equations, and we learned about linear differential equations and non-linear differential equations. So by learning these all, we are going to know that the differential equations play a vital role in our life. So there are various applications of differential equations, such as population, for finding population growth, and also in the present pandemic situations, the differential equations plays an important role for finding the death rate of COVID patients, and the number of cases rising in the country, and how many are discharged from the hospitals, and so on. So there are various uses of differential equations. Only thing that we need to do is that we need to know more about the differential equations and apply in our daily lives, and find more about differential equations, and get to invent more inventions of differential equations. that is that is our topic. um, this is the conclusion of my topic, and thank you for giving me this wonderful opportunity. Thank you.